All right, so now that we've taken a look at a sort of abstract discussion about the relationship between classes and objects, we also went into a little bit of depth about the Java API. I want to now get into a more practical explanation or a demo of creating our own custom class and then actually being able to use it in another file. So what we're going to do now is create either a project if you're doing this through an IDE, or you're going to end up creating a couple of different Java files inside of a particular folder if you want to do this through just a text editor plus a terminal of some kind. So regardless of which way you do it, this very first file, or if you make this as a project, we're going to end up calling this rectangle. So I'll go ahead and make this file. So in my case, I'm going to create a Java file that I call rectangle. If you're doing this with an IDE, you would just go ahead and create a project and call that rectangle. And then when you actually have it all set up, it will automatically create a file inside of that project that's also called rectangle.java. And then you're just going to start adding some code into that. So if you do this as a project, keep in mind that you will have some default code that it puts inside of that Java file for you. It's going to end up creating a class that already has a main method inside of it. But for this particular example, when we start off on this rectangle class, this class will not actually end up having a main inside of it. So if you have that code set up already, you're just going to go ahead and delete that main method from it because we're not going to use it in the rectangle class. Okay, so the first thing I need to go ahead and do is set up the header and the at least the initial start of the body for this. So we're going to call this public class rectangle, then have our body. And then the next thing I want to go ahead and do is start adding some content to this. So the two things that I need to add to this are going to be some data in the form of fields, basically just some variable declarations and initializations, and then a set of behaviors for this. So that's going to be the set of methods that we want to use with the rectangle class. So the first thing I'm going to go ahead and do is create my data. So the way that I want to do this, in the case of a rectangle, I want to go ahead and create two fields for this, for the length and the width. So essentially the two different dimensions that you would associate with a rectangle. Okay. So the first point that I'm going to go ahead and do, so we start off, let's go ahead and make these doubles. So since these are going to be dealing with numeric values, I'm going to go ahead and make the data type for each of them a double. So one of these is going to be the length. We'll say that this starts off initially as something like 0. So do double length is equal to 0.0. And then we'll also go ahead and do double width is equal to 0.0. Okay. The next thing I want to go ahead and do is make one quick addition to this. So I mentioned before that we want to be able to utilize this idea of encapsulation in our classes. So whenever we create our objects, we want to encapsulate the data in some way. And we want to do that through what's known as data hiding. And in order to achieve data hiding, we need to make sure that the two fields cannot be accessed in other classes. So in order to do this, what I'm going to go ahead and do is add an additional keyword at the beginning of the declaration for these variables. And the keyword is going to be the word private. So as you probably noticed before, whenever we created our classes and our methods, we always used this keyword public. Well, now for our variables, these fields that I'm going to create for this, I'm going to go ahead and use the keyword private. I'm going to do that for both of these. And the reason that I'm doing this, what this keyword is meant to achieve, is this guarantees that once I go outside of this file, if I go and create another Java file and start adding some code to that, if I want to try to make objects of this rectangle class, I cannot directly access either of these two private items or these private fields in that other file. Okay, so this helps to hide the data, or at least make it so that the user cannot directly access the data. Instead, they would have to use the methods in order to access this data. So let's go ahead and at this point, I'll go ahead and create that other file. So I'm going to make another Java file. This other Java file is going to be saved in this Java projects folder that I have. If you're doing this with an IDE, just make sure that you create this Java file in the same package as this rectangle.java file. So I'll go ahead and save this, and I'll call this one rectangle demo. Okay. And for this rectangle demo file, Go ahead and give that a header. And for this particular one, we are actually going to give this the main method. So this is where the entry point to our overall program is going to be located. So we're going to have our public static void main, add our string args, and then inside of here, this is where I can actually start making my objects. So as of right now, the only thing I've really added is just 2 private fields. So the only thing I could really do at this point is just make an object. I can't really do much of anything with it. But we'll go ahead and take a look at everything I've set up so far. So in order to create this object, as I mentioned before, we want to make sure that we specify the name of the class that this object is associated with. So it's going to be this rectangle class. We then give this a name. So in this case, I'm just going to call it rect. And this is going to be equal to a new rectangle. And then we'll include that pair of parentheses to indicate that we're calling the constructor for this. So basically what we're saying here is we want to make a new rectangle object, and then we're going to associate with that this rect variable that kind of points to or references that object. All right. So since we don't actually have any methods yet, the only thing we could really try to do is try to access these fields. So just to demonstrate real quick what this data hiding is achieving, if I do something like rect and then I use this dot notation to then go get one of the fields or methods of this rect object. Say I want to try to access the length field, and maybe I want to assign to this length field some new value, maybe something like 5.0. I'll go ahead and save that, and then I'll come over here and try to compile this code. So I'm going to compile both my rectangle and my rectangle demo. So I'm going to compile both of these things in a single line. If you're doing this with an IDE, it's still just as simple as clicking the run button or the build and run button to try to compile or build and then execute your code. In my case, it'll be a little bit more complicated since I'm doing this through the terminal, and I'll need to go ahead and compile each of these files individually. So I'll go ahead and try to compile this, and we'll actually get this error right here when I try to do this. And it's going to tell me that length has private access in rectangle, so it's giving this warning right here where I tried to access length directly inside of a separate Java file, and it's telling me that I can't do that because of the fact that I set that field to private. Okay, so what I need to do instead, if I want to be able to modify the value for one of these, I need to go ahead and make a method and make that method public, so that then I can go ahead and use that to change either the length or the width field of my rectangle objects. So coming back over here, I want to go ahead and start making these methods. So I'm going to need 2 methods, one for the length and one for the width. And the purpose of these methods is to be able to provide some new value for the length or the width, and then assign that value to these fields. Okay, so these methods are going to be public now, since I do want to be able to access this in other files. For each one of these methods, I don't need to return anything. I'm only really using this to change these values here. So I'm going to go ahead and make the return type void. And then for the name of these methods, I'm going to use a pretty standard convention for these kinds of methods, which is to use the word set and then the name of the field that I want to change. So we're going to do set length. And then right here in the parameters, I want to go ahead and pass into this something that matches the data type of the field that I'm trying to change. So we're going to have a double, and then I'm going to call this double something like new length. Okay. So the purpose here is that whenever I call my set length method, I'm going to pass into this method a double called new length, and that value that I'm passing in, that's what I want to change this length field to. So to do that, I'm going to take my length field, and I'm going to assign to that whatever value is in new length. Okay, so if I come back over to my demo class right here, instead of trying to directly access the length field and assign the value 5.0 to it, now instead I'm going to use the set length method. I'll have this pair of parentheses, and then I'll pass into there the value 5.0. Okay, so now I can actually go ahead and change that value. So if we come over here and we try to compile this again, now we can see that it actually compiles properly, so there's no errors with this. So then once I've got this compiled, the next thing I might want to try to do is actually run it. So if I try to run this code, the only thing that I need to try to run is going to be the file that has the main method inside of it, which would be rectangle demo. So I'm going to use that Java command to tell it that I want to run something. And then I only need to provide the name of the rectangle demo, the class file that I've created, so we'll do that. But as we can see, I haven't provided any sort of like print statements or any kind of output for this. So right now when I try to run this, it won't actually show anything happening. Behind the scenes, it did go ahead and change the value of this rect object that I created to 5.0. But of course, obviously, once this program finishes running, then all of this is kind of undone. So there's no persistence or nothing interesting going on just yet. So the next thing I want to go ahead and do, we'll go ahead and make another one of these methods, one of these set methods for the width. So again, this is going to be public. Again, the return type is going to be void since we don't need to return anything from this. We'll call this one set, and then the name of the field width. So we're going to call this set width. This will again take a double since the data type of width is double. We then give it a name for this parameter, so we'll call this one new width. Go ahead and create the body for our method. And right here, we're going to take the width field, and we're going to assign to the width field the value that we passed in, so whatever new width happens to be. Okay. And so once we do that, we can come back into our demo, and then right underneath this, we'll take that rect object, and we will set the width. So if our length is 5.0, let's say the width is going to be something like 3.0. Okay. And as we already noted, if all I'm doing is setting the length and width, we don't really see any output. So in addition to creating these two set methods, I want to go ahead and also make some methods to be able to allow me to access this data, so this length and this width, so that then maybe I can go ahead and access that and then print that out. So to take a look at what this is like right now, if I don't include these methods, so let's say in this rectangle demo, right after this, I try to put some print statements here. So I've got some system.out.println line. Maybe I want to try to access the length first, so I have something like rect.length. Go ahead and save that. So then if I try to compile this entire thing as it is, so go ahead and compile both of those. Again, we run into that same problem as before, that length has private access. So again, I cannot directly access it. Instead, I need to create some kind of method to be able to access it. In this case, just being able to go and get that data, not necessarily change it. So we'll come over to our rectangle, and right here we'll go ahead and create another two methods. So these next two methods now, rather than being used to change this value, they're just being used to go and get that value and then return that back to wherever the method is being called from. So for these, again, we're going to use the public keyword because we want to be able to use these methods in other files, in other classes. Instead of making the return type void, like we did for these two set methods, now we need to actually specify a return type that matches with the field that we want to return. So if we want to return the length, we see that its data type is double, so the return type for this should also be double. For the name on this one, since these use the name set and then the name of the field, for these next two methods, I'm going to use the word get and then the name of the field, so I'm going to do get length. I don't need to pass in any parameters for this one. Instead, all I need to do is just go and get whatever the field is and then return that back. So no parameters need to be specified. And instead, we're just going to have a single line right here to just go ahead and return that field. So for this one, where we want to get the length, we just want to return the length. Okay. And then we'll go ahead and do another one of these as well for the width. So same general process. Public, since we want to use it in other files. Double, since the data type of our width is also a double. Get width, since we're going to use this to get the width field. That pair of parentheses, but we're not going to provide any parameters. And then we're going to return the width. Okay. So then coming back over to our demo, instead of trying to use the length field directly here, I'm going to use my getLength method. And then underneath this, we'll have a second print statement. And for this one, we're going to get the width. Okay. Alright, so now that we've got all this set up, we can go ahead and run this. We'll see that we changed the length to 5, the width to 3, and we go ahead and print those both out. So we're going to have 5.0 and 3.0 printing out to the console. Or at least that's the expectation. So we'll go ahead and compile this. So we don't get any errors anymore, meaning that we're now accessing everything in the proper way. So we're achieving data hiding the way that we intended to. We'll then go ahead and run the rectangle demo. So we'll run the file that has the main method inside of it. And we see the values 5.0 and 3.0 printing out to the console. Okay. Alright. The next thing I want to go ahead and do, now that we've got our two fields set up and we've got these set methods and these get methods set up, I want to go ahead and introduce one last method to this, which is going to be a get area method. So the way that I want to do this get area method, I want to again provide the public keyword, so we want to be able to use this in other files. For get area, since our length and our width are both doubles, in order to calculate the area of a rectangle, we just multiply these two values together. So the expected value that we'll get from that would also still be a double. So the return type for this get area method will be double. And then I'm going to just call this get area. So it'll match up pretty much with the convention that we used for get length and get width. Okay. And then go ahead and open up this pair of parentheses. And then right here, what I want to go ahead and do is provide something like just a simple return statement. And then I want to go ahead and, rather than returning just the length or just the width, I want to return the length times the width. So we'll do return length times width. All right. So this will give us this get area method. All right. So if I come back over to my demo, using this last method that we've created, I have one last print statement here. Do rect.getArea. We'll then come over here, we will compile this, and then we'll go ahead and run it. And now we can see that we're getting 5 for the length, 3 for the width, and then 15 for the area. Okay. So one thing that I want to note about this getArea method, as you probably noticed, I didn't try to create, say, some additional method right here, maybe something like private double area. Maybe start this off at 0.0, and then maybe down here have some kind of set method. We have public void set area. Maybe this doesn't necessarily need to take any values. Instead, we would just use it to say that the area is equal to maybe the length times the width. And then right here, we would return the area. So say perhaps we wanted to try doing it in a slightly more complex way. Besides the fact that this requires adding a few extra lines of code, so it's a bit more verbose than what we did before. There's also another particular issue with trying to do something like this. So if we come over here, say I've set the length and set the width, and then I do something like rect.setArea. So this is going to calculate what the area should be at this moment, which would be this 5 times 3. So right here, the area becomes 15. And then when I come over here to print it out, if I don't do anything else, we're just going to print out that value 15. But let's say that after calculating the area here, right here, I want to go ahead and change the value of, say, my length. So we'll do rect.setLength. And right here, I'm going to change it from 5.0 to 10.0. So if I try this, I save it and I run it. Go ahead and clear what I have currently. Go ahead and compile it. And then we'll go ahead and run it. And we run into a little bit of an issue if I do things in this way, which is that the length is 10, my width is 3, but my area didn't really change along with these. And the reason that it didn't is because of the fact that anytime I change one of these two fields, I would have to recall my setArea method in order to make sure that it's updated to match any of those changes. So rather than having to do that, I would rather just go ahead and do the entire calculation and get the value all in a single method with the original way that I had written getArea. And this particular issue that we're running into, this is what's known as creating stale data, which is to say that whenever we have data that is dependent on or is derived from the data that is contained in other fields, we generally don't want to try to create a separate field for it, because of the fact that if any of those other data points or any of those other fields that it is dependent on, if those fields change at some point, then we also have to make sure that those changes are consistent across all of the fields that it's dependent on. So we're just going to go ahead and get rid of this area here. We're going to get rid of this setArea method, and then we're going to go ahead and get rid of, or at least change back the getArea to just get the length times the width. Go ahead and save that. And then right here, we don't need to make this call to setArea since we're not using that anymore. So we'll save that. And then if I go ahead and run this again, then it'll go back to just going ahead and calculating that area kind of on the fly, but always being consistent with whatever the most up-to-date version of the data happens to be. So we'll come over here, compile this, and then we'll run it. And now we can see the length changed to 10, our width changed to 3, and our area was consistent with that and changed to 30. Okay. And then of course the other thing to note about this, because we're doing it in this way, this also helps to capture that other point about encapsulation that I mentioned about implementation hiding. In addition to the fact that this helps to resolve the issue of stale data, it also helps to reduce the burden on the user of having to be familiar with the internal details of our class or any of the methods that we use inside of this class. Instead, the only thing that they really have to be aware of is just kind of the inputs and the outputs. So in this case, say like with setLength and setWidth, the input is whatever we want to change a value to. The output, if you want to call it that, is just changing the length and the width. That's the only thing that the user really needs to be aware of. In the case of getLength and getWidth, they're only really concerned with what the output is going to be, which is the length and width, those data points. And then with getArea, again, the only thing that they're really concerned with is the output and just making sure that that output is consistent. So in this way, we are able to successfully achieve both of those ideas of encapsulation with data hiding and implementation hiding. All right. Okay, so at this point, this is going to wrap up this first little part about trying to implement our own custom class and then using that in a separate Java file with our little main method set up here. Going into the next part, I'm going to take a moment to break down this class that we created in a more design-oriented way by taking a look at what's known as a UML class diagram. And then from there, we'll start looking into other aspects of implementing our classes. So one of the things you may have noticed already is that we're missing a constructor method. So I'll come back to that, try to add a constructor to this, and then also talk a little bit about adding some additional methods as well, including going through another separate example that really kind of flushes out the idea of being able to create several methods in a single class.